In this lecture, we're going to see an attempt at simplifying the syntax for function pointers using type aliases. In the last lecture, we had a chance to set up our guest-based function, which was taking a function callback as a parameter here. And hopefully you can see that this function pointer is really making our function here ugly to look at and hard to understand. And some of you might think, isn't there a better way? Isn't there a way we can really simplify this and make this function easy to understand? Well, one option to simplify this is to use type aliases, and we're going to be using the modern way to do this with the using keyword. The way you do this, you can set up a type alias for your function pointer, and the syntax is what you have here. This is going to be your new name. You will put an equal sign, and then you will specify your function pointer for which you want to set up a type alias. Once you have this in place, you can go wherever you needed that function pointer and use the type alias to set up this thing, and the compiler is going to wire these things up and make your function pointer work. Once you do this, notice that the signature of our function become a little bit easier. We know that the second thing we pass as a parameter here is a comparator, and it is something that is going to be used to compare our strings. Hopefully this makes sense to you, and it is going to make things easier in your daily job as a C++ developer. Please note that this is a matter of personal preference. Sometimes I prefer to leave in my function pointers as they are because I am familiar with this, but I am going to leave the decision to you whether to use type aliases or not. My job here is to make you aware of the possibilities. Once we have this type alias, and we can really use to do all kinds of crazy things. For example, here we can pass our function callbacks here, and things are going to work really well. But we can also use our type alias to set up other callbacks. For example, we can say str comparator and say my comparator and pass whatever function pointer we want to be used as our comparator, and we can use that in a call like we do here, and everything is going to fall in place. One thing you should know is that it is also possible to use the type def syntax to set up a type alias, and the syntax is what you see here. It is a little bit ugly to look at itself, but it can work if you want to do things this way. But I don't recommend it because this is older syntax. It is supposed to die off slower with time. So don't use this in modern C++ code that you happen to be writing in your career as a developer. Once we have this set up, we can use it like we have used our other type alias, and it is going to work. Everything is going to fall in place. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is function pointer type aliases. We will reuse the code from the last lecture because we have everything from there. And we can put the code in the current lecture and open this up in Visual Studio Code. So let's do this. This is going to give us our box container class that we can use to play with things. But the first thing we want to do is to simplify our getBest function here, which takes a callback, which is really ugly. It's going to make our function ugly, and we want to simplify these things using type aliases. So the first thing I am going to do is set up a type alias for this function callback, and I am going to say using str comparator, and I am going to specify the function pointer I have here. So we can grab this entire thing. I think we can do that. And we're going to put that on the second line to be able to follow this. And one thing you should notice is that we don't need to specify the name here because the naming of this thing has really moved to this location. So we're going to take out this name here, and this is going to set up our type alias. Now, if we go down to our function here, we can simplify it by taking out this entire function pointer and say str comparator, and give it a name, and that's going to be comparator like we had before, and everything is going to fall in place. You're going to see that this wiggly line here is going to go away, and everything is going to work. Now we have a simpler way to pass a callback to be used in our function here. And one thing I don't think I told you before is that a function that takes A callback is called a higher order function because it's really somehow sitting on top of another function that it is using as a callback. But I don't like to use this term because it confuses people. I just like to say things as they are and say that we have a function that takes another function as a parameter, and that's going to set up a callback mechanism in our C++ program. But what we are using here is the using syntax to set up a type alias. So this is going to work, and if we go down, we're going to see that our guest-based function here is going to work as it did before. We can build our code, and let's run the task we don't have a task end here. What is wrong? We didn't grab the VS Code folder when we set up this thing, so let's go back to our code here and go to callback function. We can grab the VS Code folder, which is going to give us the configurations to call our compilers and do all kinds of crazy things. And now this thing is going to have this VS Code folder, and we can run the task to build with GCC. We're going to have that in. The build is going to be good. We can clear, not clear. We can bring up a terminal window first, and we can clear now and run Rooster, and everything is going to work as we want. You're going to see that larger in size is friend and greater lexicographically is the sky string. Everything is going to work as it did before. We can even go down, for example, and specify str comparator. We can do that, and we can specify that, let's say this is our callback, and we're going to initialize this with larger in size. We can do something like this. And we can pass our callback here, for example, and say callback. You can do these kinds of things if you want in your C++ code. It is going to work. You can use your type alias to set up other callbacks you can use in your C++ program, if it happens to make sense for the problem you are trying to solve with C++. Let's pass this through our compiler, and everything is going to work just fine. The build is going to be good. We can clear and run Rooster, and you're going to see that we have the same data here. Everything is working as it's supposed to do. Another thing I want you to see is that it is possible to use the older type def syntax with these things, but I don't really recommend it because it is ugly, but we are learning, so I need to make you aware of these possibilities. So let's go down and show you that. We're going to put in the syntax to do that, and this is going to set up str comparator as a type alias to this function pointer that returns bool and takes two strings n by reference. This is going to do what we were doing before. We can even go down and use our type alias to set up other callbacks like we do on line 94 here. We can build our program, and everything is going to work just fine. The build is going to be good. We can clear and run Rooster. We're going to have our data here. Everything is going to work. But I don't really recommend this syntax again because it is supposed to die slowly with time. So in your new C++ code, make sure you use the using syntax to set up type aliases, and that's going to be your code much more readable and understandable by other modern C++ developers. Now that you know these things, I would challenge you to go in and modify functions to use type aliases. You can name the type alias however you want. And if you have some trouble, let me know. I will do the best I can to help you out. For now, this is all I had to share in this lecture. I hope you found it interesting. The syntax to set up type aliases is really simple. You can use the using syntax. It is technically possible to use type defs, but again, I don't recommend this because this is older C++ code. We are going to stop here in this lecture. In the next one, I will show you how these type aliases work with function templates. Go ahead and finish up here and meet me there.